So, have you ever wondered what really separates a good piece of software from a truly professional, secure system? Well, today we're going to unpack a master blueprint for exactly that. It's called the Orion Philosophy for Secure Engineering. And this isn't just theory, folks. This is a practical guide for building software that's actually designed to last.
This quote right here, it just nails it. Security isn't some feature you tack on at the end, right? It's not the coat of paint. It's the concrete and steel foundation you pour before you even think about building the walls. Without that, everything else you build is at risk of crumbling.
And let's be clear, what we're looking at today isn't some dusty, 1,000-page industry standard that no one ever reads. No way. This is a distilled, battle-tested methodology designed for the people who are actually in the trenches. You know, the developers, the data engineers, the cloud architects, who build and maintain real-world systems day in and day out.
All right, let's dive right in with the first pillar, secrets under lock. This is, and I'm not exaggerating, probably the most critical and, sadly, one of the most common points of failure in pretty much all modern software.
Man, this says it all. It is so tempting, I get it, to just paste an API key or a database password right into your script just to get things working. But doing that, it is a one-way ticket to a security breach. The second a secret like that gets committed to a public code repository, you have to assume it's compromised. Seriously, automated bots can find it in minutes and start causing chaos.
Now check this out, because the fix is actually incredibly simple, but so important. On the left, we've got that hard-coded secret just sitting there. But on the right, we decouple the secret from the code by using an environment variable. It lives outside the code, in the environment where the app actually runs. And here's a little pro tip for you. Using the .get method is absolutely key. It makes sure your app doesn't just crash and burn if the variable is missing. Instead, it just returns none, which lets your code fail gracefully and, more importantly, securely.
You can kind of think of this whole secrets management thing as a journey, a maturity model. Everyone starts somewhere, right? And that's usually hard coding things. But you quickly level up to using environment variables, which is way better. But the final, professional, enterprise-grade step, that's using a dedicated secrets manager, something like Azure Key Vaults or AWS Secrets Manager. That's the big leagues.
And the benefits of doing that are just huge. A secrets manager gives you this one central control panel. You can kill a compromised key instantly without touching a single line of code. You can automatically rotate credentials, which shrinks the blast radius if one ever gets exposed. You get a full audit trail of who accessed what and when. And that last point is super important. Never, ever store a big blob of structured data like JSON as a single secret, because pieces of it can accidentally leak into your error logs.
Okay, so we've got our secrets locked down tight. Now what? Well, now we have to secure the perimeter. That's where pillars 2 and 3 come in. They are all about playing defense, controlling what kind of code comes into your system and who gets access to it.
This is pillar 2. Look, modern apps are built on the shoulders of open-source giants, right? But that means our code is only as secure as all those third-party libraries we import. And this isn't some hypothetical threat. The OWASP Top 10, which is basically the list of the biggest security risks on the web, consistently flags vulnerable and outdated components as a massive problem.
So how do we defend against this supply chain risk? With something called Software Composition Analysis, or SCA. Think of it like an automated background check for every single one of your project's dependencies. Tools like Snyk or GitHub's Dependabot will scan your code, check all your libraries against a huge database of known vulnerabilities, and sometimes they'll even create a pull request to fix it for you. It's a game changer.
So just like we scan the code coming in, we have to scrutinize the users coming in. And that brings us to pillar 3, access control. The philosophy here is so simple, but it's incredibly powerful. When you give someone access, you give them a specific key for a specific door, not the skeleton key that opens the entire building.
This idea has a formal name, the principle of least privilege. And it is the golden rule of security. You grant the absolute minimum set of permissions that a user or a system needs to do its job, and not one permission more. In the real world, we do this using role-based access control, or RBAC. You know, defining roles like admin or viewer, and giving them only the specific keys they need. All right, we've locked down our secrets, and we've fortified the perimeter. Now it's time to shift our focus inward, to the structural integrity of the application itself. Pillar 4 is all about writing resilient, defensible code.
The number one goal here is to defend against what are called injection attacks. This is when a bad actor tricks your application into running commands it was never supposed to, usually by feeding it some specially crafted data. It's one of the oldest and still one of the most dangerous types of attacks out there.
And here's the classic textbook example, SQL injection. On the left, you can see that the user's input is being directly stitched or concatenated right into the database query. This is unbelievably dangerous. The definitive fix is on the right. Use parameterized queries. This technique forces the database to treat the user input strictly as data and never, ever as executable code. It just completely neutralizes the attack.
And it's not just SQL. We have to be really careful about how we handle any external data. For you Python developers out there, the pickle module is a perfect example. It's powerful, sure, but it can be a loaded gun. If you deserialize a pickle object from a source you don't trust, an attacker can basically run any code they want on your machine. So the rule is simple. For any external data, always prefer a safe, simple format like JSON.
But here's the thing. Even with the strongest walls and the most secure code, you are completely blind without visibility. And that brings us to our final pillar, building the watchtower for your application through logging and monitoring.
This quote is just the absolute truth when it comes to incident response. When something goes wrong, and trust me, eventually it will, your logs are the only record you have. They're the source of truth for figuring out what happened, for doing a forensic investigation, and for proving compliance. Without good logs, you're flying blind. You can't defend your system.
But logging presents this interesting challenge, a kind of paradox. You need to log enough detail to actually be useful. Things like failed logins or when an admin does something important. But at the same time, you have to be incredibly rigorous about sanitizing your logs to strip out any sensitive data, like passwords, API tokens, or personal information. If you don't, your logs can go from being a defensive tool to being a massive security liability. And there we have it. Let's just quickly recap the 5 pillars that make up this whole blueprint. 1. Secure your secrets. 2. Fortify your dependencies. 3. Engineer access control. 4. Write resilient code. And finally, number 5, intelligent logging and monitoring. You put those together, and you have a complete, professional framework.
Ultimately, this is what it all boils down to. Implementing these pillars isn't about being paranoid or always expecting the worst. It's about professional discipline. It's a mark of true craftsmanship. It shows you're not just building something that works today, but something that is reliable, trustworthy, and secure for the long haul.
So I'll leave you with this final thought. Think about the last project you worked on, the last piece of code you shipped. After going through this blueprint, ask yourself, honestly, was it built on the solid rock of these security principles, or was its foundation maybe made of sand?